Okay, today um, I took this paper for mathematics in the Edexcel syllabus, right? Advanced level your mathematics one, right? So you know the structure of this paper. Uh, I'll talk about each of these sections these slides, right? Basically. F of x equals ax cubed plus 10x squared minus 3ax minus 4, right? Given that x minus 1 is a factor of f of x, find the value of the constant a. You must take your method a1. Okay, so we have factor theorems and remainder theorem at the very beginning of the syllabus in pure mathematics, right? So first of all, we have conversions and rationalizing denominators, and after that, quadratic functions and equations, and then polynomial functions and factor theorems and those remaining theorems, related theorems like that, right? So we will use factor theorem, right? You may able to use alternative method even with the help of long division, right? I think somehow I'm trying to do this using factor theorem, right? X minus 1 is given as x minus 1 is given as a factor, right? When x minus 1 is given as a factor, it's a factor of f of x. Then we can apply when x equals 1, apply factor theorem, right? Factor theorem. When x equals 1, f of 1 equals a times 1 cubed plus 10 times 1 squared minus 3 times a times 1 minus 4. This is minus 3, right? This should be equal with 0 because it's a factor. It can be divided by x minus 1 with no remainder, right? So what about this 10 and this minus 4, minus 3 with minus 2a is taken to the other side with 2a. 6 equals 2a means a equals 3, right? A equals 3. Right, okay. Then we have evaluated the value of a when a x equals 1, you can check it again. 10 minus 6 minus 4 is 6. Then this is minus 3a plus a, it's taken to the other side, then 2a equals 6, then a equals 3. Right, okay. Then what is the alternative method you can use? I'll show you the alternative method. Then you will be given marks for showing these steps. You are written by what is the theorem you have used, then method and answer. You will be given 3 marks for that, right? Then accurate answer A1, then N1, method, like that in the print, right? Okay, what is the alternative method? Even you could use long division, right? Long division. In terms of long division, f of x can be divided by x minus 1. So what about f of x? F of x equals ax cubed plus 10x squared, ax cubed plus ax cubed plus 10x squared, 10x squared minus 3ax minus 4 is divided by x minus 1, right? So this becomes ax squared ax cubed minus ax squared. This part cancels off with 10 plus a x squared minus 3ax minus 4, right? Actually, I don't recommend this method because it takes a little bit time comparatively or respectively, and you want to make some advanced methods in order to find out the constant value, right? So this is divided by well, this becomes 10 plus a times x, then 10 plus a times x squared minus 10 plus a times x. This is divided, these are cancelled off, right? And now you can see this is minus times, this becomes plus minus, yeah, sorry. This becomes plus 10, right? And this becomes plus 10. When we subtract these two, this becomes plus 10 and this becomes plus 8, then minus 2a x minus 4, right? Then again 10 minus 2a, then 10 minus 2a times x minus 10 plus 2a. Okay, now we will get the subtraction, right? And get the subtraction, then you can see 6 minus 2a, right? So this should be equal to 0 because they have given x minus 1 is a factor of f of x, so then there should not be a remainder. So while we are getting the remainder is going to be equal to 0 with no argument. Then a equals 3. You can see clearly both answers are going to be equal. It should be happen because both these methods are correct. It's approaching the requirement, but I think the long division takes a little bit time compared to even if we will not follow this, right? Okay. Right. The second question, given that f of x equals x squared minus 4x plus 5, x is an element of real number set, right? We know real number set for a real number set, number system. The first one, it is formed with, it is starting with natural numbers. We know natural numbers. They are 1, 2, 3, like that, up to infinity, right? So after that, all numbers including 0, right? The integers, we can split them into two parts, plus integers and minus integers, including even 0, right? Then rational numbers is it's a kind of number that can be presented as a ratio between two integers, but the denominator is not going to be equal to 0, and denominator and numerator are not having common factor except excluding 1, right? So that's the those are conditions to be the rational number. So there are two types of decimal forms. One is finite decimal and other one is recurrent decimal, right? So likewise, the rational numbers can never be interpreted like I said earlier, right? How do we identify that? Is we cannot interpret as ratio between two integers like denominator is like currently equal to 0. Those conditions will be violated, right? So the properties of this irrational number is just we can never stop it by finding out decimal forms because there is no strategy, there is no ending point, right? It will be a it will be an infinite decimal. Infinite decimal, right? Okay, after that, transcendental numbers, right? non-standard numbers are just all these are algebraic numbers. This can be a root of any algebraical equation while non-standard numbers cannot be, right? For example, pi and e exponential, right? Pi and e, they have their own defined functions with tan inverse and e to the power x, the Maclaurin series, right? Expansion of Maclaurin series. So likewise, all these numbers are non-natural numbers, right? So then this is what they need, right? Any of the real number can be taken by x, right? Okay. It's actually if you know all these things, I think it will be helpful when you move forward, right? Okay. So this I wanted to explain this section on the express f of x in the form x plus a squared plus b, where a and b are integers to b form, right? Okay, it's nothing else. It's just easy. What is this? You can see x is trapped inside a squared. It is given as a perfectly squared. This part is shown as a perfectly squared, right? So we can use the squared method. Squared method is, can be used, right? F of x equals x squared minus 4x plus 5. When we divide this coefficient of x is divided by 2, then it is minus 2. Then what I do is I get the square of that. When I get the square of that, it becomes plus 4. And it's something wrong because there is no plus 4. So I used to put minus 4 or negatively to cancel out that effect, right? So now what you can do is you can identify this as this is the square of x minus 2. Square of x minus 2, right? Then with minus 4 plus 5 will be simplified and it becomes plus 1. You can see that when we compare x plus a squared plus b, a is just minus 2, right? A is just minus 2 because x plus minus 2. There are only 2 operators. All the other operators are formed with the combination of it. It can be made with various kind of ratios. All these operations, even in calculus, all of them are formed with these 2 operations. They are just summation and multiplication, right? Right. Okay. Then b equals little b equals 1, right? Right. Okay. The curve with equation y equals f of x means the y-axis at the point P has a minimum turning point at Q. Write down the coordinate of P and the coordinates of Q. Right. Okay. Curve with the equation y equals f of x, right? Y equals f of x, then y equals f of x equals my given function, which is a quadratic form, right? So this is a kind of polynomial function. The degree is 2, and this is known as a quadratic function, right? Means the y-axis at point P. Means the y-axis means x when x equals 0. When x equals 0, we can find out y, right? When x equals 0, we can find out y. Y equals 0 squared minus 4 times 0 plus 5. Then y equals 5, right? Y equals 5. So this is the point, right? 0, 5. This is the coordinate of P, right? This is the coordinate of P. Has a minimum turning point at the point Q, right? Okay, so point Q. So the square method. When you talk about a square method, there are a couple of advantages. There are 3 major advantages can be introduced when we talk about a square method. Most of the students think that a square method is adapted for finding out roots or factorizing incorrect expression. No, actually, it's not mean by square method, but converting or turning any kind of any type of quadratic expression into this format is known as square method. Using square method, that can be converted into this format, right? So what are the advantages of using square method? There are three major advantages of using square method. One is we can find out roots of quadratic equation using square method, right? Actually, there are three types. Roots can be distinct, real distinct. Roots can be overlap together, right? They are real but they are same. They are all together. Then, and the other one is the roots can be complex conjugate, right? Most of the students used to say they are imaginary, but the accurate one is roots are complex conjugate, right? So there are three types of roots like that for quadratic equation. So any kind of quadratic equation can be solved with the help of the square method, because x is trapped inside inside a parentheses. There is a square, then you can easily make x the subject, right? And otherwise you can factorize using square method. How do you factorize it is you can write down this any part as a square, and you will be astonished with that, because it becomes a positive part. What will be happen? If it's a positive part, no need to worry. We can write it down like this, and we can express this as a we can express this as an imaginary number, right? So likewise, it becomes a complex conjugate. These factors are coming up with complex conjugate factors, right? So likewise, the third one is very useful, and we will use this in order finding out turning points, in order finding out minimum or maximum. Actually, we used to call them vertices, right? Vertices can be found out regarding quadratic function in quadratic format. Vertices can be found out with the help of square method, right? So that's what I'm going to do. Then what I'm going to do is I will let this quadratic square part be 0, x minus 2 be equal to 0. Then most of the students are wonder with this, why we let this be equal to 0. Actually, I will explain it by taking a little bit time using the same example. You can see when we plug this, this is just a parabola, right? I'm not going to plug this anyway. This becomes a parabola, right? The shape of this quadratic function is just a parabola, right? It's just a parabola. Then you can see always this is not an one-to-one function, because any y value can take towards values corresponding abscissa values corresponding domain values, right? So two corresponding domain elements can be taken for a single codomain element, right? For each of them. But you can see when we talk about the vertex, it is something quite different, because all these are all up together. When we talk about this vertex, these two x values are all up together. So that's the point we are looking for, because we are looking for the vertex, right? So you can see when we talk about this squared expression, I'll show you an example, right? For example, I asked you to substitute x equals 3. What happens? 3 minus 2 minus 1. This c is just 1 squared plus 1 squared, right? No need to just simplify this. You can keep it there, right? Keep it there. Right. Okay. All right. Now I ask you to substitute just x equals 1, right? Now what will happen? Y equals 1 minus 2 squared plus 1, right? What about this? Minus 1 squared plus 1, right? So no need to simplify this. This is minus 1 squared, right? This is plus 1 squared, right? You can see that's how a single y value is having two corresponding X values, right? So like that, there are so many. Even within our single lifestyle, even we can never count all these values, how many values are there, because x tends up to plus infinity and x tends up to minus infinity from the time, right? So that's right? Then we are looking for the position which where the where there is a y value which is having only one single x value, because actually they are all together. This is occurred while these are having plus or minus sign, right? So what is the position? It has no plus or minus value. It's just zero, right? Zero has no plus or minus exactly. So we can let this be equal with zero in order to finding out the verdicts, right? Uh, what we are looking for. X equals 2, right? When x equals 2, there is the verdicts, right? When x equals 2, you can see y equals x minus 2 squared plus 1. When we let this part be equal to 0, x equals 2, right? And then when x equals 2, this becomes 0, and then y equals 1, right? Okay, what is the coordinate of the verdicts? It is just 2 comma 1, right? So coordinate of q will be 2 comma 1. So actually we can do this promptly within a few seconds. I wanted to explain you that I wanted to give you a better idea about all these. That's why this is to play, right? Okay, it's time to go. I have some more tasks to do, right? Okay, see you later. There are some more questions. Hope you enjoy.